All right, let's get right into it. Apple has this huge, ambitious plan to bring some seriously powerful AI to your iPhone. But here's the catch, right? To get that kind of power, you usually need the cloud. And how do you do that without just handing over all your private data? Well, today, we're going to unpack Apple's big answer to that very question. It's called private cloud compute. So here's how we're going to break it all down. First, we'll tackle the big AI privacy dilemma. Then, we'll dig into Apple's 5 key promises. After that, we're cracking open the black box to see how this thing actually works. We'll look at the tech that builds all that trust. And finally, we'll zoom out and see why this could be a whole new standard for AI. Okay, so here's the core issue, the big trade-off we're all facing. For the really smart next-level AI, your phone just doesn't have the horsepower on its own. It needs the cloud. But the second your personal data, your messages, your photos, whatever, leaves your device and hits some remote server, well, that's where the privacy risks really begin. And this isn't some abstract problem, it's something we should all be thinking about. Think about it. When you type something into an AI chat, where does that question actually go? Who has access to it? And can you, really, truly be sure that your private conversations are going to stay private? Yeah, this isn't just theory. It's happening. Just this year, an AI company, DeepSeek, leaked about 100 million sensitive records from their user chat logs. That's a lot. And it's exactly the kind of nightmare scenario that keeps people at these tech companies, and frankly, us users, awake at night. And what's really wild is that even when you think you're being careful, like clicking on a private mode or something, it might not actually matter. Some AI companies, their own policies say they might have to hold onto your chat data anyway, no matter what you select. So a company just saying, we promise to be private, isn't a real guarantee, is it? Apple knew they needed something way more solid than just a promise. So to fix this trust problem, Apple decided not to just write up another privacy policy. No, they went a different route. They actually engineered a solution from the ground up based on 5 strict rules, 5 promises that are literally built into the code. Okay, so these 5 promises are the foundation of everything. The big ones are your data is never stored. And again, this isn't just a promise, it's enforced by the tech itself. It's less like someone saying, I promise not to look in your diary, and more like the diary is written in disappearing ink. The system's also built with no backdoors for anyone, not even Apple, and it's designed to make it super hard to single out any one person's data. But really, it's that last promise that's the linchpin, the one that makes the whole thing work. And that last one is verifiable transparency. This is the absolute game changer. It basically means it's not enough for Apple to just tell you they're following the rules. No way. This promise means your own iPhone can actually check for itself. It uses some pretty heavy-duty crypto to basically demand proof from the server that it's running the exact approved software and nothing shady on the side. This is the bedrock of the entire system's trust. So how do they actually pull this off? How do you take a regular old server, which is essentially a black box, and transform it into something your phone can trust with your most private information? It's all about building up layers of trust. So you start with that typical black box server. First, you add a layer of anonymity, which basically scrubs your identity and your IP address from the request. Then comes the magic trick, the verification step. This is where your iPhone literally interrogates the server to check its software before it sends a single byte of your data. And to top it all off, they harden the whole system. We're talking no hard drives for storage, no remote shell access for engineers. It's physically designed to be impossible to spy on. That whole anonymity part is super clever. And there's a perfect analogy for it. Think about going to an arcade. You walk in, you exchange your money for a bunch of generic tokens. From that moment on, the arcade owner has no idea which specific machines you are playing. Your iPhone does basically the same thing. It gets an anonymous token to make its request, totally severing the link between that request and your actual Apple ID. All right, now let's get a little geeky. Let's zoom in on the 2 key pieces of technology that make this entire system of trust possible. They're called remote attestation and the transparency log. So first up, remote attestation. That's the fancy name for that verification step we keep talking about. Basically, your iPhone acts like a bouncer. It tells the server, hey, before I let my data in, you need to show me some ID. And that ID isn't just a name. It's a cryptographically signed receipt proving exactly what hardware and software it's running. So here's how that little back and forth goes. Your iPhone asks, "Hey server, what are you running?" The server comes back with a signed list of claims saying things like, "I swear I'm genuine Apple hardware, and I'm running this exact approved software." It also hands over a public key. Now, if your iPhone is cool with those claims, it uses that public key to encrypt your data. And here's the kicker. That encrypted data can only be unlocked by a server that perfectly matches those claims. If a single thing about that server changes, poof, the key's useless. But wait, how does your iPhone even know which software claims are good? That's where the second piece of the puzzle comes in, the transparency log. The best way to think about this is like a public, unchangeable bulletin board. On this board, Apple posts a list of every single software binary that's allowed to run in its private cloud. Anyone, you, me, security researchers, can go look at this log. So when your phone gets that proof from the server, it just checks it against this public list to make sure everything's legit. Okay, so Apple has built this fortress of privacy. It's incredibly robust. But what does all this mean for the rest of the industry and for the future of AI? Let's zoom out and look at the bigger picture. Look, there's no such thing as a free lunch, and this kind of privacy definitely has its costs. These are serious trade-offs. All that encryption and verification adds latency and compute cost. For the engineers trying to maintain it, it's a total headache. Imagine trying to fix something when you can't even log in remotely to see what's wrong. It also completely messes with business models based on tracking usage. And, for now at least, it's a walled garden, closed off to outside developers. But here's what's so important to understand. While Apple's specific system is their own, the ideas behind it aren't magic. They're not secret. For pretty much every single piece of their private cloud, from the secure hardware to the transparency log, there's an open source or publicly available version that does a similar job. This means other companies can and are building systems just like this. Apple essentially laid out the blueprint for everyone else to follow. And believe me, the market is definitely following. It's been like a domino effect. Since Apple dropped this announcement in mid-2024, we've seen the other big players scrambling to keep up. Microsoft's Azure announced they're working on something similar, and Meta rolled out a private processing system for its AI that, when you look at the architecture, is almost a carbon copy. Apple didn't just join the conversation, they changed the entire conversation. They raised the bar for everyone. So, in the end, Apple has drawn a new line in the sand. They've set a completely new standard for what private AI can, and maybe should, look like. But this whole thing leaves us with a really big, fascinating question for the future. In this new world where trust isn't a promise, but something verified by code, who gets to decide what trustworthy actually means? Who holds the keys to that public log? Because whoever controls that, well, they get to decide which software and which ideas get a seat at the table. And that's something we're all going to have to think about as this becomes the new normal.